Hello, dear B.Sc. second year students. Now today I will going to talk about aldehyde ketone topic, a continuous episode. So as already you are very familiar with the concept of aldehydes and ketones, what are the functional groups are there. Now let me start the point with some of the point already I have discussed in the last episode. The first point is both aldehyde ketone possess carbonyl group, that is C double bond O, and oxygen is more electronegative compared to the carbon. Therefore, it will acquire minus charge and carbon will be ultimately positive charge. And if the two valencies are satisfied by alkyl and aryl group, it is a ketone, or alkyl and alkyl group is also ketone. If one of the valency is alkyl and hydrogen, that is a aldehyde. So all these discussions is over, and naming is already according to UPAC nomenclature. The aldehydes are named as alkanals by replacing E by Al, and ketones are named by replacing E by ONE, alkanone. Okay, aromatic aldehydes having a basic concept of benzaldehyde as a benzene ring, and the functional group or ring attached with some other group can be named by certain numbers. Then for benzaldehyde, that is a phenone. For acetophenone, you might have seen the functional group C6H5CO group. It is generally referred as a phenone, and the other groups attached to it, that is a methyl phenyl ketone, may be represented in a different fashion. So I don't want to discuss all these points which I have discussed so far last time. Okay, now let us see this particular property I am concentrating. That is the carbonyl group is having sp2 hybridized carbon with bond angle 120, and the loop of pz orbitals are overlapped above and below, and this molecule is generally having plus charge delta plus, partial delta plus on carbon, and partial delta minus on oxygen. That is the polarity of the carbonyl group I have represented, and this pi bond can be shifted very easily towards the oxygen, and that makes to exhibit a resonating structure with plus and minus charge. Okay, so this is a very important property while we are discussing or understanding the reaction mechanism. So I will come to the next slide. Okay, so this slide already I have discussed last time, but it is inevitable to explain. That is a nucleophilic addition reaction. That is a nucleophile means NUH generally we prefer. So these nucleophiles, when come into contact with the carbonyl compound, so carbonyl compound C is plus, O is minus. Okay, so the nucleophile will attack to the carbon and O will become minus, and H will be attached later on to form additional product. So this mechanism last time I have explained with the step 1, the unsymmetrical breakage of the nucleophile, okay, in the step 1. And the second step, the nucleophile will attack to the carbon plus site and giving anion, and this anion will be stabilized by addition of a proton. This is called a protonation. So this already I have explained, and this nucleophilic addition can take place in two ways. One is by acid catalyzed, another is by base catalyzed. So in case of acid catalyzed reaction, so this is a condition, that is a nucleophile in acid H plus gives the product containing NuOH, that is a hydroxyl nucleophilic substituted product of the carbonyl group. So this case, what happened in the first step, the carbonyl group will attack with the H and will become OH plus, and carbon will be plus, and further it is resonated to form C plus and OH. So that cation will going to form, cation react with the nucleophile to form the nucleophilic product attached to the carbon. So in case of acid catalyzed reaction, the beginning starts the reaction with addition of H plus. In case of base catalyzed reaction, the nucleophilic reagent, but is a weak. So because of the weak nature of the nucleophile, we have to use a strong base. strong base replaces the H and produces nucleophile, and that nucleophile in the same manner in the acid catalyzed reaction will react to the carbonyl group plus carbon and forms anion. Anion will further react with the Hb and giving the final product. So all these reactions you are familiar. Now last time I have mentioned one reaction, that is addition of hydrogen cyanide. Here hydrogen cyanide ionizes to give H plus and Cn minus. So this means there is a formation of cyanide anion as a nucleophile. Okay, so this anion will attack to the central carbon to form a cyanide group attached with oxygen having negative charge, anion molecule, and this anion further undergo addition of H plus, that is a protonation, to give the final product containing Nu attached with OH. So that I have given here. So you can see in this particular three steps of this reaction. Okay, so sometime what I used to do is, uh, wherever it is possible, I will draw the chem draw or from some internet connection structures. Otherwise most of the cases I used to give in written form, because the written form indicates that we are unable to take all the information from the net, or sometime we cannot I cannot do the work with a computer. So that is why wherever possible I have just quoted some these written material, so don't ignore them. So they are also very important. Okay, so the cyano group which is formed will undergo hydrolysis as well as reduction to give RCHOH COH, that is a carboxylic acid, and RCHOH CH2NH2 amino compound. Okay, so these are the two reactions steps which are essential, and the two reactions I have given. Okay, then you can see the specific example for your convenience. I have given that acetaldehyde when treated with HCN forms cyanohydrin of the acetaldehyde, or acetaldehyde cyanohydrin. Similarly, acetone under condition with the same HCN gives acetone cyanohydrin. Okay, so these are the two reactions. Now similarly you can see the reaction with the hydroxyl amine. So in case of hydroxyl amine, what happened, NH2OH is a hydroxyl amine. When treated with a aldehyde or ketone, so there is a formation replacement of O and H2 as water, two hydrogen of amine and oxygen of the carbonyl group, and the resulting is CH3C double bond NOH and at the bottom H, that is cyano. Here it is a oximes are formed. RCH double bond NOH is an oxime. So the reaction pertaining to this, last time I have explained. So it is again my duty to tell you what is this reaction. So RCHO is a written form I have given, an aldehyde or ketone generally react with the hydroxyl amine, that is NH2OH, to form RCH double bond NOH plus elimination of water. And mechanism is very simple. Already you noticed carbon will be plus and oxygen will be minus because of electron rich center oxygen or electronegative oxygen. Protonation takes place, make the OH with lone pair of electron, and carbon will become plus. Then it will attack with your hydroxylamine. So in case of hydroxylamine, NH2OH, nitrogen is having lone pair of electron. These lone pair of electrons shifted to the carbon and making an unstable anion. And this unstable anion loses a proton just in the second step I have shown. So whereby elimination of water take place and there is a formation of C double bond NOH. So this is a mechanism in connection with the hydroxylamine. Sometime in examination they may ask, explain the mechanism of addition of that is a cyano group or OH group, NOH group to the aldehydes and ketone. So a cyano group is there, that is a cyanohydrin formation, and here it is a addition of hydroxyl amine to give the corresponding. So please note step by step the reactions. Okay, so now with this you can move to the another, that is reaction of aldehydes and ketones with alcohols. Okay, so with alcohols, okay, with alcohols, that is means ROH, you can see here. When the aldehyde treated with R-OH or R1OH, it will going to form RCOHHOR1, that is hemiacetyl will going to form. The same hemiacetyl will react with the another alcohol molecule to form acetal. So what is this acetal? Acetal is a carbon containing OR1, OR2 and H, that is two alkoxy groups attached. So acetals are nothing but diethers, a gem diethyl compound. So just I have shown. Okay, so in general please remember, one molecule of alcohol react with the aldehyde to form hemiacetyl, that is the OR and OHH. So you can see R1OR is a ether. Similarly, other molecule forms diether. It is called gem diether. Okay, so this is how the addition of a alcohol molecule takes place. And I have given a specific example here at the bottom. You can see here. When RCH, acetaldehyde, react with alcohol, there is a formation of hemiacetyl, and hemiacetyl further react with another molecule to form acetyl, that is a gem molecule. Gem means two COH groups are attached with it. Okay, and regarding this mechanism, let us see. RCOH is an aldehyde reacting with R-OH, first molecule of alcohol, to form hemiacetyl, and second molecule forms acetyl. And the mechanism involves protonation first. The RCH double bond O aldehyde undergo protonation means addition of proton to form RCHOH plus. So OH plus. And this what happened, undergo resonation, and the double bond shift and oxygen will become the cation, and that proton shift, lone pair of electron shifts towards oxygen. Similarly, addition of alcohol, second molecule of alcohol, and deprotonation means removal of the proton takes place in the second process. RCOH having a negative sign. Okay, and then ROH directly attached because the lone pair of electrons are there. So those lone pair of electrons get transferred to here carbon plus cation. Just I have mentioned that is not a minus, it is a cation. So in the first step itself, RCH plus OH. RCHOH plus in the second step react with the alcohol, where the lone pair of electrons on oxygen will going to form RCHOH OR dash H. In the last step, the proton elimination of the second molecule attached to alcohol to give your hemiacetyl. Okay, so this is a mechanism proposed. And now for the second step. In the third step, what happened? Protonation again occurs. Here you can see what is the kind of protonation you can see. That leads to form RCHOH. H will get become H plus added, and it will become the oxygen with positive with two hydrogen. And the removal of water molecule leads to makes the central carbon to positive. Okay, then the lone pair of electrons were shifted within the molecule, and you will have RCH double bond O R dash. Okay, that is a cation. This cation will react with another alcohol molecule and undergo a positively charged anion. This undergo deep disproportion or deproportion to form your corresponding acetyl. Okay, so like this the corresponding acetals are formed with alcohols. Okay, so already I have discussed all these things, and that is why a little bit I am moving fast for these reactions. Okay, then when you talk about the reaction of alcohol to form a cyclic acetals, that is cyclic acetals. For example, when you treat ethylene glycol, what is ethylene glycol? OHCH2 single bond CH2OH. When treated with acetaldehyde in presence of para-toluene sulfonic acid PTS. So there is a cyclization occurs. That means the O of the aldehyde and two hydrogens will eliminated as a water molecule, and cyclization occurs to give your cyclic product. Okay, with reference to acetone I have shown acetone, ethylene, ketol. With respect to aldehyde it will form acetaldehyde, ethylene, acetal. Okay, so correspondingly whatever the kind of aldehyde or ketone used, that name is treated. And finally, if aldehyde is there, you have to write it as acetyl. If ketone is there, you have to write it as a ketol. Okay, now with this let us see the mechanism. For this mechanism, that oxygen is negative, carbon is positive for the carbonyl group, H plus attacks, and that H plus makes the protonated molecule having plus charge attacks to the glycol, and that glycol having the H plus now forms a glycosidic linkage of oxygen to the your corresponding aldehyde, and this will remove the proton. Deprotonation takes place, and you will get OH attached to the glycosidic ring of the carbonyl group. Then again I have shown the arrow mark with the proton addition, that is a protonation, H plus, that will become H2O plus. This H2O plus undergo dehydration, removal of water to form a product of this kind. Okay, product of this kind, that is a C double O, I think it is, yes, O double bond C, CH2 CH2 OH. The lone pair of electron on the oxygen of the one end will move towards the carbon and the double bond shifts, and whereby you will get CH2 CH2 O O, and the carbon this carbon containing two valencies, that is it may be aldehyde or a ketone. Now in the next step, what happened? The proton of the oxygen containing plus charge will be get removed off, and the double bond will be created, the lone pair of electron are shifted to the oxygen, making CH2 CH2O carbon with two valency and O, and joined to the CH2, a cyclic ketol is formed. So this is the mechanism. Please note this mechanism very carefully. Sometime the question may be asked on this: what happens when this aldehyde or ketone undergo cyclic acetal or ketol formation? Please explain. Then you have to use an example, using one example with this mechanism, right? Okay, this also last time I have discussed. Now iodoform reaction. So what is this iodoform reaction? So sometime 2 marks question, the examiner may ask you, write the iodoform reaction for aldehydes or ketones. So aldehydes do not undergo this iodoform reaction, only ketone, because when a ketone containing methyl group is warmed with a solution of iodine reagent, a yellow PPT of triiodomethane is formed. Okay, that is a CHI3 will going to form. Here the iodoform reagent is prepared by dissolving iodine in NaOH, that is alkali, or KOH. This test is generally used for methyl ketone group present in ketones. Okay, so it's only for ketone, that is you can see here this reaction RCOCH3 plus 3I2 plus NaOH. When it is heated, it will going to form the RCONA, an acid carboxylic acid, plus CHI3, that is iodoform, and HI will be eliminated. So this reaction, please note it very carefully. Okay, so sometime in 2 marks question, write iodoform reaction. Just you can write whatever the reaction I have shown and what is the meaning of iodoform. That's all. Okay, so this is all about the iodoform reaction. So please note it very carefully. Now in the side, another way, I have represented an alternate method of a mechanism of a cyclic crystal formation. In the previous slide I have shown, but it is a little bit easy to understand, but the same thing whatever I have represented, I have made it in ISO draw and convince to you as far as this concern. Then now most important is aldol condensation. So these are the called name reaction. What is aldol condensation? When aldehyde, particularly benzaldehyde, is treated with another molecule of aldehyde or ketone in presence of a base, undergo combination of these aldehydes or two ketones or one aldehyde one ketone to give an additional product, and the additional product is known as alpha beta hydroxy corresponding aldehyde and ketone. So this reaction is known as aldol condensation. So let me give you this again. RCH2 C double bond OH is an aldehyde. RCH2 C double bond OH, this is an aldehyde. When these are treated in presence of a base, the combination took place and one of the carbonyl group will become OH and another carbon group as it is. So this is what we call RCH2OH CHH C double bond OH alpha beta hydroxyaldehyde alpha beta hydroxyaldehyde. Okay, so this is, now you can see another example here. When you take acetophenone and treat with a benzaldehyde, there is a formation of a product alpha beta hydroxy ketone, aldehyde. It contains hydroxyl group as well as ketone. So just I have shown this for your information. So another type. Now here I have another example. You can take CH3COH. So acetaldehyde molecule when treated with NaOH, they combine to form alcohol containing group and carbonyl group. So the condensed product is called as acetaldehyde containing a ketonic group, that is alpha beta hydroxy alpha beta. Just you can see the C double bond or red, next carbon is alpha carbon, next carbon is beta, next is a delta. So on beta position there is a OH group, that is what is called as a beta hydroxy, and the C double bond is at the one end, therefore it is a ketonic group, beta hydroxy ketones or aldehydes. That is nothing but aldol formation. Okay, so similarly you can have another example pertaining to this CH3COCH3. So same thing is diacetone alcohol, because we are using here CH3COCH3 acetone when treated there is a formation of diacetone alcohol. Okay, so it is again alpha beta, there is a beta hydroxy alcohol. So this such type of reaction are known as aldol condensation. Well, I have shown the mechanism here, and here again I come across with my routine method of showing in a handwritten format. So I think handwritten format sometime will be more better than the whatever the represented here. You can see two aldehydes in dilute NaOH undergo aldol condensation. Okay, so in the first step what happened, the OH group, hydroxyl group, removes the proton to form anion. So this anion is generally known as enolate anion, CH2 minus COH. So which also undergoes formation of CH2 double bond CO minus H. So enolate anions will going to form in the first step. Now in the next step, what happened? This enolate anion attaches or come in contact with the second molecule of aldehyde. So second molecule of aldehyde is having carbonyl group, so O minus and C plus. So at the plus site of the carbon of the second aldehyde molecule, the enolate anion attacks, and there is a formation of anion CH3 CHO minus CH2 C double bond OH. Okay, so this molecule undergo protonation by water molecule. Okay, H attacks to the O minus to form CH3 CHOH CH2 COH. So there is a formation of alpha hydroxy butanol, alpha hydroxy butanol, NaL. Okay, so aldehyde and OH minus. Okay, now here you can observe one thing is the aldol condensation may take between two identical or two different aldehydes or ketones, or it may take reaction with one aldehyde and another ketone also. Okay, so this is a very simple reaction. Sometime for you 5 marks question of aldol condensation may be there. Please note this. Okay, now whatever the reaction I have shown, the same thing will be in the typographic form. You can see the first molecule of aldehyde react with OH. There is a formation of CH2, that is the enolate anion, CH2 minus C double bond OH, and that molecule come in contact with another molecule of your aldehyde, and where the minus charged carbon will shift towards the oxygen and makes anion of the second kind. Now in the third step, what happened? That anion undergoes hydrolysis to give your final product CH2OH H CH2COH. So condensation of two different aldehydes, condensation of two different ketones, or aldehyde and ketone in presence of an alkali leads to form beta hydroxy aldehyde and ketone, and is known as aldol condensation. So please note this reaction. Then now the similar kind of reaction, it is called as a benzyline condensation. So what is benzyline condensation? When you can see the reaction better, when two molecules of benzaldehyde allow to react with alcoholic cation, then the condensation between the two molecules similar to the aldol condensation, giving benzyne. So this reaction is known as benzyne condensation. I repeat again, when two molecules of benzaldehyde allow to react with alcoholic cation. So remember, it is not aqueous, it is alcoholic cation. Then what happened? The two molecules undergo addition, and there is a formation of C6H5CHOH alcoholic group and C double bond ketonic group and C6H5. So this product is called as a benzyne. So here, as you can see, when an aromatic aldehyde like benzaldehyde reacted with alcoholic cation, the two molecules undergo self-condensation to form alpha hydroxy ketone known as a benzyne. This reaction is known as benzyne condensation. Right? So mechanism for this reaction, you know, cation undergo ionization to give K plus and Cn minus. And in the first step, what happened? Benzaldehyde come in contact with the Cn minus. So Cn minus goes to the carbon and oxygen shifts electron, making anion A. This anion A further will going to form the anion C6H5CCnOH. So the proton shift within the molecule takes place. Okay, the H of the C6H5CHOH O minus will shift its electron, making carbon anion B. Okay, so this is a first step. In the second step, the anion B will with come in contact with another molecule of your benzaldehyde, and whereby you will get a huge molecule of anion C, C6H5C CnOH. Then again COH OH and C6H5. Here you can see C6H5 Cn, the first molecule Cn, OH, and the negatively charged carbon will attack to the another molecule of your benzaldehyde to give the product C. And here in this product C, the proton transfer takes place. That is, the proton of OH group shifts towards the negatively charged oxygen, and you will get a C6H5CH O minus and CHOH. So earlier the negative charge is there on the second oxygen. It shifts here because of proton transfer within the molecule. And in final step, the product D undergoes deprotonation, that is the removal of cyano group, and uh, removal of cyano group and the shift of the lone pair of electron carbon to oxygen makes C6H5 C double bond O CHOS C6H5. So this is called as alpha hydroxy ketone. Alpha hydroxy ketone. It's commonly known as benzyline condensation. This reaction is very important to in the view of your point of examination. Sometime they may ask you, explain benzyne reaction with its mechanism for 5 marks. Mechanism is very simple. Just you practice it once or twice at home. Definitely you understand it. Here in this case, the rapid loss of Cn minus reacts with the K plus to form uh, regeneration of KCN. So that already you have learned in your many classes. Okay. Now I think Claisen condensation. So what is this Claisen condensation? When two molecules of aldehyde, okay, two molecules of aldehyde, where there is no alpha hydrogen, treated with NaOH, okay, at a laboratory temperature in aqueous condition. The two molecules undergo oxidation and reduction. One will going to form alcohol and another will going to form acid. Okay, so this is a reaction where self oxidation and self reduction occurring simultaneously within the molecule. Such reaction is known as what we call as a Kennesaw reaction. In Kennesaw reaction, let us see here. In Kennesaw reaction, you can take formaldehyde or you can take benzaldehyde. Better I will go with the benzaldehyde as the best example. Benzaldehyde, two molecules when treated with aqueous KOH or NaOH. So one molecule will get converted into benzyl alcohol and another will be converted into sodium benzoate. Sodium benzoate. In this particular reaction, what happens is the nucleophile OH minus generated by ionization of KOH attacks to the positive side of the your benzaldehyde carbon and making anion A. Okay, so this is first step. I repeat again, the OH minus, that is the nucleophile generated by ionization of NaOH. So this attacks to the carbon of one benzaldehyde molecule and make the anion of a corresponding benzaldehyde. Then in the second case, what happened? The negatively charged anion will come in contact with the second molecule of your benzaldehyde. Here the anion loses its proton and which goes to the second benzaldehyde molecule, making C6H5CH2O minus, and the previous one will become C6H5O minus will become double bond and OH, that is benzoic acid will going to form, right? So the anion loses its proton, make it to be benzoic acid, and the proton will move towards the carbon and making the second benzaldehyde molecule to benzoyne anion B. This benzoyne anion B now undergo exchange of proton. So you can see C6H5COH react with C6H5CH2O plus along with Na. So Na replaces the proton to make it as a sodium benzoate, and the replaced hydrogen will move towards the second positively charged benzaldehyde molecule. So that makes a CH2O plus to CH2OH. CH2OH. So here is a small correction by mistake. It is CH2O minus, not CH2O plus. CH2O minus. So CH2O minus will take a proton from the benzoic acid and make it into benzyl alcohol, and then there is sodium benzoate. So this conversion of two molecules of benzaldehyde into benzyl alcohol and benzoic acid, the sodium benzoate, in presence of alkali is a self under is a reaction of the kind where oxidation and reduction occurring simultaneously in both the molecule. So this is the same thing, just you can see in the different fashion. Okay, so you can see two molecules, one will get converted to benzoic acid, another will be benzyl alcohol. So the mechanism, just whatever in the three steps I have shown, this is the case where in the first case OH minus attacks and there is a formation of anion. Second aldehyde molecule attacks and there is a formation of benzoic acid and your benzyne anion. And proton transfer makes this as C6H5CO minus. That is a benzoic acid, that is a loses a proton, and the loosed proton will go to the second aldehyde molecule, make it to alcohol. Okay, and finally protonation makes C6H5CO minus as a, that is acid. Acid and alcohol are simultaneously formed. So my dear friends, so with this let me complete today's episode, and almost all reaction mechanism which are essential for you I have discussed. Now let me tell you that there may be 7 to 8 different name reactions for you. So I request all of you, just as far as possible, download our YouTube videos, and if possible you go through slowly and read out all the points I have discussed and make the reaction to be written by your own hand and practice at home, so that you will get a good number of marks and good knowledge of your entire syllabus. So with this few word, I want to conclude this topic saying that stay home, wear mask, and social distance is compulsory. So thank you, one and all.